Some things feel like magic, but they're actually just math. And today, we're going to crack the code on one of the most mind-bending forces out there, exponential growth. Let's get into it.
All right, let me start by asking you something that sounds, well, completely nuts. Could a single sheet of paper reach the moon? I know, it sounds like something out of a sci-fi movie, right? But stick with me, because we're going to find out.
Now, this probably brings back some memories from school, right? Trying to fold a piece of paper as many times as you can, and in the real world, you hit a wall really fast. I mean, most of us can't get past 7, maybe 8 folds before it's just this tiny, thick brick that won't bend anymore.
Okay, but for our little thought experiment here, let's just pretend we can ignore physics. What if we had this magical sheet of paper with no limits? We can fold it as many times as we want. So, what happens then?
So here's the one simple rule that changes everything. It's the key. Every single time you fold it, the thickness doubles. We're not just adding a little bit each time. Nope. 1 layer becomes 2, 2 becomes 4, 4 becomes 8. You see where this is going.
All right, so keeping that doubling rule in mind, how many folds do you think it would take to get to the moon? 1,000? 1,000,000? The answer is going to blow your mind. It's shockingly small, just 46.
And there it is, that's the big reveal. Just 46 folds. That's all it takes for a piece of paper thinner than a millimeter to become a stack so tall it reaches the moon. I know, it sounds completely impossible, but that's the wild, beautiful, and kind of weird truth of this whole power play.
So you're probably asking, how on earth is that even possible? Well, let's break it down. We're going to visualize this incredible journey to the sky, step by step.
Okay, check this out. This is where you can really see the growth just explode. After 10 folds, you barely got a centimeter, no big deal. But then, look at the jump between 17 and 26 folds. You go from the height of a kid to almost touching the top of the Burj Khalifa, the tallest building on the planet. And then, get this, just 4 more folds and you're at the cruising altitude of a plane. The growth isn't just fast, it's accelerating like crazy.
I mean, these images really put it into perspective, don't they? We go from a skyscraper to where jets fly in just 4 folds. The stack of paper isn't even on the ground anymore. It is literally up in the clouds.
It really does feel like a magic trick, doesn't it? But it's not. It's pure math. So let's pull back the curtain and see what's really driving this thing. It's time to crack the growth code.
The phenomenon we're looking at has a name: exponential growth. And if there's one word you need to burn into your brain, it's multiplicative. We're not adding, we're multiplying. And trust me, that one little difference changes absolutely everything.
This slide really nails the difference. See, with additive growth, that's the linear stuff, it's slow and steady. 4 plus 4 plus 4 is 12. Predictable. But multiplicative growth, that's exponential. It's explosive. 4 times 4 times 4 gets you all the way to 64. It's the difference between taking the stairs and launching in a rocket.
Now, to deal with this kind of crazy growth, mathematicians came up with a handy shortcut. It's called exponential notation. So instead of writing out 2 times 2 times 2 over and over again, you can just write 2 to the power of 7. The base, that's the number 2, is what you're multiplying. And the exponent, the 7, just tells you how many times to do it. Simple, right? All right, so I think you're getting the hang of this. Let's put that new knowledge to the test with a classic riddle. It plays on the same kind of tricky idea. You ready for it?
So imagine a magical pond. And in this pond, you've got these lotuses that double in number every single day. Now, on day 30, the pond is completely full. So here's the question. On which day was the pond half full? Now, your first instinct might be to say day 15, right? Half the time. But remember that doubling rule we've been talking about? The answer is day 29. Think about it. If it doubles every day to become full on day 30, then on the day before, it had to be half full. It's just simple logic, but it feels so wrong. This is another perfect example of how the really dramatic, explosive part of exponential growth happens right at the very, very end. This whole doubling thing pops up in old stories and riddles all the time. So let's look at one more example, one final power play. This one's about a king, and of course, a whole lot of treasure. So this one starts out sounding like a classic fairy tale, but, surprise, it's actually a math problem in disguise. It all starts simply enough. A king has 3 daughters. But from there, the power of 3 just starts to multiply, branching out and over and over. Let's just walk through this. You start with 3 daughters. Each one gets 3 baskets, so now we're at 9 baskets.
Each of those 9 baskets has 3 keys, so that's 27 keys. And each of those keys opens 3 rooms, bringing the total to 81 rooms. And believe it or not, the riddle isn't even done yet.
So the riddle keeps going. It talks about tables, then necklaces, and finally diamonds. And at every single step, the total gets multiplied by 3. So when you add it all up, from the daughters all the way down to the diamonds, the total number of jewels is 3 to the power of 7. And that is the elegant mathematical answer to this king's clever riddle.
So whether we're talking about folding paper or counting a king's diamonds, you can see how exponential growth leads to these results that they defy our common sense. So what's the big takeaway here? Well, the next time you hear that something is growing exponentially, could be technology, an investment, anything really, just remember the paper and the pond. All the really huge, game-changing growth happens right at the very end. Thanks for diving into this with me.